Hello, this is part 3 in a series of videos on the latitude of the planets. We are going to look at the geocentric latitude of Mars. And as we will see, the geocentric latitude of Mars is very interesting. It does some peculiar things. We're going to learn a little bit about why Mars has this interesting behavior with its latitude. So this image here at the top, it looks a little bit sloppy, but the basic idea of what we're trying to show here is that this is Mercury, Venus, Earth, and Mars, orbits going around the sun. The yellow circle in the middle is the sun. The blue circle on the right is the Earth. The red circle is Mars. And what we're showing here is that when Mars is opposition to the sun, it can have a very high latitude, because the latitude of the planet is the angular distance between the ecliptic plane, this horizontal line, and I've drawn a red thick line horizontally to the right, and a line drawn from the Earth through Mars. And when Mars is opposition to the sun, it's very close to the Earth. And because it's close to the Earth, relatively close as it will ever get to the Earth, its latitude becomes greater. So that's what's happening. And we will look at some charts and see, we'll see this in a little more detail. So again, the geocentric latitude of Mars can become more extreme than the heliocentric. Why? Because heliocentric Mars is always a similar distance from the sun. We know that Mars travels in an elliptical path, so it's not exactly the same distance from the sun, but it doesn't vary very much, and therefore the angle between a line drawn from the sun to the Earth and sun to Mars, it's going to just go up and down very regularly. But from the Earth's point of view, it's not nice and regular and even. So this is the nice, even, pretty, symmetrical thing you get heliocentrically. So what we're looking at here is from 2000 to 2020. So this is 20 years of the latitude of the planets. You just go into the Sirius software, you select the graphic ephemeris, right-click on the graphic ephemeris, and check the box for latitude, for heliocentric latitude, and you will get this graph. And then you can select what planets you want in the graph. You can select all of them. Sometimes when I do a large number of years, I remove Mercury because it's so fast, it makes so many peaks. But over 20 years, we can leave Mercury in, and you see that Mercury goes up and down fairly evenly. They will all be fairly even. There's actually some variation in how high it gets and the spacing between them because of the elliptical orbit of Mercury rather than being perfectly round, but it's almost perfectly regular. And on the left, it's very small, so you may not be able to read it. This is 0 degrees in the center, and this is 4. And this is 8 degrees. So we have 0, 4, 8 degrees north and 0, 4, 8 degrees south. So Mercury, which has an inclination of 7 degrees, so therefore its maximum latitude is 7 degrees, and it's nice and evenly distributed across. And we see Venus, which has an inclination of a little more than 3 degrees, going up and down to that little bit more than 3 degrees, the light green that you see here. And the red that we see here is Mars, and its inclination is a little bit less than 2 degrees, so it's going a little bit less than halfway from 0 to 4, and a little bit less than halfway from 0 to -4. In other words, going almost to 2 north and almost to 2 south, very evenly. So this is what we get. And we can also see here, if you look very carefully, Jupiter is this purple one. I don't know if you can see that very well. I'm tracing it with my cursor. There's Jupiter going up and down. And the black one is Saturn, peaking here in almost the middle, maybe a little bit right of the middle. And this red one coming from the top is Pluto. And Uranus and Neptune are also in here, and they're light blue and green, and they're staying very close to zero. Kind of difficult to see. They're kind of merged in there. So anyway, that's the heliocentric latitude of the planets. Nice, beautiful, I'm calling it beautiful. In other words, simple pattern that it makes. And of course, geocentrically, it's not this nice, simple, wavy thing. It's rather interesting. So look at Venus, the green one. It starts high, 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 low, high, high, and then a big high. So it's going like, we'll call it up and down. So from here, it's going up, up, way down, up, way up. Almost like a rhythm, like it's starting here would be like up, up, down, up, 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 up. If I give an emphasis to how high it's going, it's like up, down, up. So it's got this kind of rhythm where every 3 or 4 ups, it becomes extremely up, and same thing with the down. Kind of interesting. And the Mars pattern is very peculiar. It starts high, 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 and then the deep low. And I mentioned at the end of the previous video that it makes these highs, they're like peaks and a rounded bottom. So it's like rounded bottom, peak, rounded bottom, peak, round, and then the ups start getting rounded and goes down with sudden peaks. And across the 30 years, this is from 1995 to 2025, Mars has 2 big dips downwards where the geocentric latitude, again, this is a graph of geocentric latitude, goes all the way down. It looks like about 7 degrees south. Very interesting. Makes us wonder as astrologers, does something interesting happen on these rare occasions when Mars will make this sudden deep dive to a very, very low geocentric latitude? Well, we're going to look at what's happening in the sky when Mars has a very, very far south geocentric latitude, which means going down, it looks like somewhere between 6 and 7 degrees south, looking at this graph. Okay, so now, this is just showing if the 2, making it clear, these 2 times over this 30-year time period from 1995 to 2025, that Mars makes this very low, reaches this very low latitude. This one here appears to be in late 2018, looking at the legend down here for dates, late 2018. This one looks like late 2003. So every once in a while, it goes way down. We're going to see what's going on here. Oh, I give the exact dates. So Mars geolatitude is 6 South 35 from August 2nd to 6th, 2018. Okay, so this right here, where I've circled in black, from August 2 to August 6, so for about 5 days, the latitude, the geocentric latitude of Mars is very, very low, around 6.5 degrees south latitude. So August 4th would be right in the middle, about when Mars reaches its farthest south latitude. Now, what is happening? How is it? Let's go back and look at this. How is it? Why does Mars go all the way down to 6.5 south latitude only 2 times over 30 years? What's so special about these particular dates? One of them is August 4, 2018. What is special about them? What causes Mars to go to this extreme south latitude, extreme for Mars, goes all the way down to about to 6.5 south latitude, is this. What happens is that it happens when Mars is out about 20 degrees Aquarius heliocentrically. So when Mars in the heliocentric chart is at about 20 degrees Aquarius. What's so special about 20 degrees Aquarius? It's 90 degrees before the heliocentric Mars North Node, because the heliocentric Mars North Node is where the path of Mars comes up and reaches the ecliptic plane. 90 degrees later, at about 20 degrees Leo, Mars reaches its highest point. So when Mars is over here, in fact, there's a little red dot here, that's Mars. In this image, this red dot, if you can see it where my cursor is, Mars is at its highest point. So Mars will reach its lowest latitude when it's 90 degrees before the North Node. It'll reach its highest latitude when it's 90 degrees past the North Node, and it reaches an extreme low latitude when the Earth is close to it. So here, this circle with a cross is the astrological glyph for the Earth. This is the Earth. When the Earth is also at 20 degrees Aquarius in the heliocentric chart, I've put a circle and a dot over the sun. So here's the sun. When the Earth is conjunct Mars in the heliocentric chart at 20 degrees Aquarius, that is the special situation. Okay? So you now know why. Let's go back to this graph. Why does Mars go all the way down to 6.5 south on these rare occasions? Because it's just when it happens to be that heliocentric Mars is about 20 degrees Aquarius and heliocentric Earth is conjuncted. When this happens, Earth, very simple, Earth conjunct Mars in the helio chart around 20 degrees Aquarius. And what you can see in this graph is, look at the distance between Earth and Mars. This little pink area, this pink a circle here. It's like track of pink between the Earth, the orbit of Earth and the orbit of Mars. This is where it's smallest. Why is it smallest here? Or what shows us that it's smallest? The Mars perihelion happens to be 6 Pisces. So what happens with Mars is that the perihelion of Mars at 6 Pisces is not extremely far away from the point where Mars is square the North Node at 20 Aquarius. They're fairly close to each other. Actually, the Mars perihelion would be on the other side. They're within 16 degrees. But we're going counterclockwise. I should have put the Mars perihelion above Mars, not below it. It's 16 degrees after the position of Mars here at 20 Aquarius. So when Mars is at 20 Aquarius, it's only 16 degrees away from the perihelion. It's over here. Look how far Mars is from the Earth when it's at 20 Leo. When Mars and the Earth are at 20 Leo, they're much farther away. So the point is this. When Mars is at 20 degrees Aquarius, it's reached the square to the North Node at its lowest point in its orbit, and at that lowest point, it happens to be close to the Earth. It's just a coincidence, you could say, that the Mars perihelion happens to be near the point where Mars is lowest, and therefore, just for the planet Mars, because the perihelion is close to the point where Mars squares the North Node, and Mars is 90 degrees before the north node, that those two are within 16 degrees, you're going to get an extreme southern latitude. When Mars is up here, Mars will have an extreme north latitude, but it won't be as much. This is why. Mars at its extreme north latitude only reaches about 4 degrees, a little over 4. At its extreme south latitude, it reaches over 6. Let me say that again. The geocentric latitude of Mars, maximum is about 4 degrees north. Its maximum south latitude is 6 degrees. It seems counterintuitive. Like, why would Mars reach a greater south latitude than it would north latitude? Why does it go all the way down to 6 south and only 4 north? The reason is because when Mars reaches its lowest point in its orbit, it happens to be near perihelion. It's just a coincidence, you might say. And therefore, the geocentric latitude of Mars can go all the way down to 6.5, but its north geocentric latitude can only go to about 4 north. So it'll go from 4 north when it's here at 20 Leo, and if it's conjunct the Earth, if the Earth and Mars are conjunct at 20 Leo, like here, when you have this peak, this red peak here, where Mars reached 4 north, that's when Mars is conjunct the Earth at about 20 Leo. This downward peak, which is steeper, goes all the way to 6.5, goes all the way to 6.5 south. That's when Mars is conjunct the Earth in the heliocentric chart at 20 Aquarius. Anyway, I've repeated it so many times, maybe I'm making this more complicated than it is. Very simple. Mars conjunct the Earth at 20 degrees Aquarius. Mars will get near 6.5 south. So that's what's happening. That's what's happening. The coincidence that the Mars perihelion happens to be near this 20 degrees Aquarius makes the Mars south latitude go very, very far south. And here's the chart. So if you're looking at a chart, this is the chart for August 12th, 1971. That's not on the graph I showed earlier because I started in 1995. But if you go back to the 1970s, you'll see another one of these Mars going very, very far south, and it reaches 6 south 51. That's the most extreme one I found, almost 7 degrees south. So Mars reaches an extraordinarily south latitude. What if you have a client born on August 12th, 1971? That client, anybody born on August 12th, 1971, or within a day or two of that, the latitude of Mars has reached extraordinarily, unusually far south, all the way down to 6 south 51. Does it mean something? I mean, for mundane astrologers, what was happening in the world in mid-August 71? This is an interesting thing to research. And if you just look at the chart, the way you would detect that this is likely is there's Mars at 16 Aquarius, Sun at 18 Leo, and I put the planetary nodes in here. This is the heliocentric nodes of the planets. Mars, North Node at 19 Taurus. The nodes move a little bit. In 1971, if you round it off, it's 19 Taurus. We did it for previously in the previous videos in the series. I think we were doing 1996. And I think the Mars node was at 20 Taurus. It moves a little bit. 19, 20 Taurus, somewhere in that range is what you'll have for people that are alive today. So Mars heliocentric node at 19 Taurus is square the Sun at 18 Leo and Mars at 16 Aquarius. This is the normal chart that we do, geocentric. Heliocentrically, instead of Mars opposition the Sun, it's going to look like Mars conjunct the Earth, right? So, when planets are opposition geocentrically, when Mars is opposition to the Sun geocentrically, it means it's conjunct the Earth heliocentrically, and there it is. And look at how tight this is, extremely tight. Mars at 18 Aquarius, conjunct the Earth at 18 Aquarius 36, half a degree orb. And they are 90 degrees before the Mars heliocentric north node at 19 Taurus 21. The whole thing is within a little more than 1 degree. So it's very tight. Mars is tightly conjunct the Earth, and both of them are tightly, very close to exactly 90 degrees before the Mars heliocentric node. That is the situation that causes Mars to have an extreme geocentric south latitude. And the heliocentric latitude of Mars, by the way, reaches almost 2 degrees south, and there it is, 1 south 51. That's as far south as Mars ever gets, a little bit less than 2 degrees south heliocentric latitude. We're looking at the heliocentric chart. I've put a purple box and yellow highlighted. This is the heliocentric chart. All I did in the series software is go to coordinate system and select helio. So in the helio chart, Mars is at its maximum south latitude, 1 south 51, which it always does when it's 90 degrees before its heliocentric node. And going back to the helio chart, because this Mars Sun is square the heliocentric node of Mars, and the doing it geocentrically, Mars is 90 degrees before the node. It's also at an extreme, unusual, something that happens very rarely, goes all the way down almost to 7 south geocentric latitude. So, it's just understanding how the planets move. You see it most clearly by looking at the helio wheel. That's where you'll see it, in a way, the clearest. The orbs will match the latitudes the most clearly. You have this perfect square, all within 1 degree, and you have the extreme south latitude of Mars. So very, very interesting. Just helping to understand why Mars will make this dip all the way down to over 6.5 south latitude on very rare occasions. Why does it happen? It happens when in the heliocentric chart, Mars is conjunct the Earth at around 19 or 20 degrees Aquarius. That's simple. If that should ever happen, Mars will be at an extreme south latitude. It'll be extreme south helio latitude, which means almost 2 degrees, and it will be at an extreme south geolatitude as well, which is more than 6.5 degrees south in the geocentric latitude. So that's it. You can also call, in the series software, you can select the planetary listings table, and here I'm showing what happens on August 4, 2018. This is a different date, only a few years ago, when the latitude of Mars reached 6 south 35. Now 6 south 35 is not as extreme as 6 south 51 that we saw in this chart in 1971. So in 1971, on August 12, 1971, Mars went all the way down to 6 south 51. There it is, right there. Mars is at 6 south 51. Later, much later, in 2018, also in August, when the Sun is in Leo, is when this will happen. On August 4, 2018, Mars also gets to an extreme south latitude, not as extreme as the other one. This one is 6 south 35, doesn't reach 6 south 51. Why is it not as extreme? Because the alignment is not as tight. You see that the Mars heliolongitude is 9 Aquarius. It has a 10-degree orb to the Mars North Node at about the time its opposition, the geocentric Sun. So it doesn't all coordinate. It doesn't all happen at the time that the Mars Sun opposition occurs is not right exactly square the Mars helio node. It happens a little bit before at about 9 or 10 degrees Aquarius Leo, so it only goes to 6 South 35. The more that it lines up perfectly, that the Mars Sun opposition happens if it happens right at 19 to 20 degrees Leo Aquarius, and from the helio point of view, as we see here, from the helio point of view, it's a conjunction in Aquarius. If that happens right around 19 to 20 degrees Aquarius, that's the most extreme. And we got very, very close to that on August 12th, 1971. So it's just a coincidence. If you happen to get a heliocentric Mars conjunct Earth at 19 to 20 degrees Aquarius, you're going to get this extreme latitude. And if it gets fairly close to 19 to 20 degrees Aquarius, it'll get close to that most extreme latitude, which we see here. So that's it. Now this is interesting. Here we have a graph of the geocentric latitude of Mars for 100 years, from 1930 to 2030. I didn't expect to see such I didn't think about it ahead of time. I just went in the Sirius software, selected graphic ephemeris, selected geocentric latitude. I unchecked all the planets except Mars. It's very easy to do. And this is what you get. So it's interesting. It looks almost like an arch to me, doesn't it? It's like here's that extreme Mars south latitude occurring 1, 2, 3. Here it happens twice, like we'll call that 4, 5, 6, 6 or 7 times. 6 times it goes down. 1, 2, 3, 4, 5, 6 across the 100 years. These are the times when Mars is conjunct the Earth around 20 degrees Aquarius. Happens to happen 6 times, fairly evenly distributed, 6 times in those 100 years. Very, very interesting pattern, isn't it? Looks almost like tunnels, like 1, 2, 3, 4, 5 and a half, or 6 tunnels, like almost like you could, or like arches, like archways you would walk through. Anyway, it's an interesting pattern that it makes. And notice again, the maximum north latitude is a little over 4. This number here is 4. The maximum south latitude is a little more than 6. That's a big difference. 4 and 6 is like 50% more. It's going way much further down. And just for fun, I'll show you. Well, I'll show you the fun thing. Where did I do it? Here. Just for fun, I drew in this green thing. I don't know. Just to see these arches. They look kind of like tunnels or archways on the bottom, and more like smooth mountains on the top. Anyway, I just colored that in. And I also colored in at 6 degrees a yellow line to show that the maximum south latitude does go below 6th. Here's 6 degrees north, and you see it's not getting very close to that. And in gray, I put 4 degrees. So you see the maximum north latitude going just above this gray line and going way below the gray 4 south. So this was just to make clear how much farther south the latitude goes, and I don't know, just playing around with the shape of it for fun. Okay, where was I? Okay, so this is where you could say zoom in to August 1971, So when I looked at this graph, I saw this one here as one of the lowest ones, and with 100 years, this is saying May 1967, September 72. So you can move the cursor in the program. I could show you. I can do it later. But anyway, you can just do it yourself. It's simple. Just pull up the graphic ephemeris. When you move the cursor at the bottom, it will show you the date. And I saw that it was somewhere in around August 71. So then I just did a graph for 1971. And that's like a detail to see the Mars coming down there just before the middle of August. And yeah, so that's when Mars reached that extreme south latitude. Okay, well, we looked at, no, we didn't look at this. This is just if you do the listing in the Sirius software for August 12th. So again, see this lowest point looks like it's a little bit less than halfway between August 1st and September 1st. And sure enough, if you do the listing for a chart done for August 12th, there's the 6 South 51. There's the sun. It happens to be at 18.5 Leo, almost exactly opposition the Helio Mars and the geocentric, not the geocentric, the heliocentric Mars at 19.5 Taurus. This is just showing you what we looked at before. We already saw this in the chart wheel, that this is all very exact. Anyway, one reason you might want to look at the listing is that it confirms that the perihelion, the perihelion of Mars is at 5.5 Pisces, not very far away from the 19 Aquarius that squares the North Node. 19 Aquarius to 5 Pisces is about 16 degrees, right? 19 Aquarius, you'd have 11. Yeah, it's about 16 degrees, fairly close, which we saw before. What I'm referring to is, just go back to it real quickly, is this, that this perihelion point is very close to the square point, making the graph go all the way down to 6.5 south. So that's it. That's what I wanted to show you in this video, is just understanding why does Mars go all the way down to over 6 degrees south latitude, only up to a little more than 4 degrees north latitude. Now you know why. You know when it happens. You have to look at it in terms of the heliocentric chart. And just to review, what's happening is when Mars is 90 degrees before the North Node. This is true for any planet. When any planet is 90 degrees before its own heliocentric node, it's at its lowest point in the orbit. When it's 90 degrees past its North Node, it's at its highest point. That's kind of obvious. With the moon's nodes, we call that the bendings. When the moon is, this is very important, it was used in medieval astrology. When the moon is squared its nodes, it's at its highest and lowest latitude. Same thing with the moon. In fact, this is an ancient idea. Let me say that again. When the moon is 90 degrees before the moon's north node, it's at its lowest point. It's kind of obvious, because when the moon is conjunct its nodes, it has no latitude by definition. That's what the moon's nodes are. They're the points where the moon has no latitude. When the moon is 90 degrees past its north node, it's at its highest latitude. And those points of the moon being squared its nodes were considered to be very important in some of the medieval astrology. It's something that, we've lost track of in modern astrology. And if it's true that when the moon is conjunct its nodes, its north nodes or south node, or square, if that's important, maybe any planet conjunct or square its own nodes are important. It's like an oscillation. It's like a It's like when the planet reaches that high point, maybe it's stretched it to its highest point. It's like sliding up and then back down. So this chart, let's look at this. Let's just look at let's finish this by looking at the normal chart we look at. The normal geocentric chart. If somebody has Mars opposition the sun and 90 degrees before the node, you have an extreme oscillation. But anytime Mars is at 19 Aquarius, you know what we're saying here? We're saying that Mars in mid to late Aquarius has a certain tone quality to Mars. And so you can look at it like this. 19 to 20 degrees of fixed signs are very critical for Mars. Well, that would actually be in the heliocentric chart. So Mars at 19 to 20 degrees in the heliocentric chart, 19 to 20 degrees of fixed signs are critical points. And in the geo chart, when Mars is conjunct or opposition the sun, it's also aligned heliocentrically. So in the geo chart, what you have is if Mars happens to be opposition the sun, with Mars at late Aquarius and sun at early Leo, you're getting this extreme south latitude. Okay, well, anyway, there's this oscillation going on. It's very, very interesting to think about. We're going to look at some charts later with some ideas. In fact, in the next video, we're going to look at an interesting thing that happened. I'll give you a preview to this. When was this? In February 1st, 2020. I'm going to give you a preview to the next video. Okay, to the next video in the series. We're going to talk about February 1st, 2020. Very late January to early February, centered right around January 31st. January 31st to February 4th, Mars, Jupiter, and Saturn all were at zero, almost exactly zero latitude. So in this oscillation that goes on as planets move up and up above and below the ecliptic plane, they all reach this fundamental point. We're going to talk about what that might mean. We're going to look at the graphs and get some ideas of how we might interpret the latitude of the planets. Okay, that's it for now. I'll see you in the next video in this series. Thank you very much for listening. God bless. Namaste.